All right, hello and welcome to the final review. We made it to the end of the semester. Pat yourself on the back for that. So I'm going to go over non-programming stuff and then a lot of Python, okay? So that is the plan, and so let's get started with the non-programming stuff. So stuff that might appear like in an essay on the final, things like that. Okay, so let's start with Kantianism. We love our boy Immanuel Kant. He studied, among other things, ethics, which is the idea of trying to classify, like, what things, how can we describe the things that are right in this world, that are good in this world, okay? And so he tried to make sense of that, and he came up with some maxims or some ideas that he thought transcended any particular idea. And so here were his maxims and how he chose to view the world as he discovered, okay, this thing's right, this thing is good. Okay, so he thought that you should act in the way that you would want everyone else to always act. So like that golden rule thing. He likes that. Kant is all about that. And so you don't get any special exceptions. That's the main key here with Kantianism. No special exceptions. I have to tell my murderer where I am, okay? It's bad to lie in Kantianism, right? And then also you don't want to treat people as a means to an end, which Kant found a way to argue that these two are equivalent, but we can just take them both as his ideas, okay? So again, lying is something that Kant is very much against, and I guess let's pretend that a murderer didn't want to kill me, but he wanted to kill my friend. So I am not allowed to lie to this murderer and tell them, oh, my friend's, he's in Arizona right now, okay? That's something that Kant wouldn't allow, because that is not acting as you would want other people to act. If you ask them a question, you would always want the right answer back and not a lie, okay? So most people would want to lie in this situation, but Kant would be, he would say no, okay? That's where he puts his foot down. So you use these different ethical theories to try to understand what to do. It's not like a hard and fast rule, because I don't think anybody would want to do this, okay? Another example is stealing. Why is it okay to ever steal? Kant would say no, because that's a horrible thing. We wouldn't want people to steal from us, so we can't steal from them, okay? Even if it was to feed our family. So again, Kant would be against that, and that is Kantianism in a nutshell, okay? So just remember his maxims, that's how he viewed the world, and that's how he discovered or tried to make sense of what is good, what is right to do, okay? That is Kant. And now we have Mill, who thought things a bit differently. His ethical theory was called Utilitarianism, okay? He was a proponent of utilitarianism, and that ethical theory is all about maximizing your utility. So what is good? What makes you happy? For every possible thing that you're trying to analyze, for every potential action, you want to maximize the utility / happiness that results from that action. And remember, this is for everybody at once, okay? You don't just consider your own utility for making a decision and then decide, okay, yeah, this one gives me the most utility, so I'm going to do it. You have to maximize utility for the entire group of the human race, right? Maximize their happiness too, okay? So it can't just be about you again. So there's kind of a bit of an overlap here on no special exceptions. And so yeah, utilitarianism, long word, is all about the consequences of what you do, okay? So you got to look at every different person, like here's your act, and here's all the different like butterfly effect things that it could eventually do and result in. You have to discover, okay, are all of these different things that my one act could cause good for everyone? You have to compare that versus what's going to happen if you don't do the thing. Some different things might happen. And you need to judge, okay, which one gives the most utility / happiness to the most people, okay? So, yeah. Maximize utility for everyone as a whole, not just you. And so Mill would say, yeah, it's okay to murder one person just to save 50 others, okay? That is the idea. The utilitarianism people would like to save those 50 people, even if that means they have to murder one person. Okay, so that is how you can justify that kind of stuff with utilitarianism. And so that's kind of where Kant might disagree. Okay, Kant would say the opposite here, because you would never want yourself to be murdered, right? So that is Kantianism versus utilitarianism. They give you a way of analyzing some kind of idea, some kind of topic, and maybe they can help to discover which one's the right thing to do, okay? Using them together is always a good idea. All right, so now let's move on to fallacies. So fallacies are just things that you can do wrong when you are making an argument. You're trying to argue something to somebody, and a fallacy is what you get when you argue your argument incorrectly, when you argue it wrong. So think about a stereotypical, like all your family together at Thanksgiving, you're debating, somebody's debating, everybody's getting angry, and there's a lot of silly arguments going around the table, right? That's usually all of them are full of fallacies. Okay, so think about that in the back of your mind. And then also, yes, a fallacy it's an error in reasoning, but in this class especially, we want to make sure that we name every fallacy. It's not good enough to say, oh yes, there's a fallacy here because there's an error in the reasoning. No, we have to give the name of the specific fallacy that occurred and analyze why that fallacy applies here. Okay, so make sure that you remember that every fallacy has a name. You can't just yell fallacy and expect me to agree with you. Okay, that's the idea. And we learned a ton of different fallacies, and you probably found some more on Wikipedia for your essay. So I found some cool memes, and I put them on the next slide. And so we'll talk about them and analyze why they have a specific kind of fallacy. Okay, so let's start with the one on the left. All right, so go ahead and read this. Get it in your brain. So you get, would you press this button? You get $50,000, but the person you hate most gets $100,000. And this guy who apparently hates himself gets $150,000. Isn't that fun? So this is a false dilemma fallacy, this first bit. Okay? It's, remember, this is like the black and white fallacy as well. This is saying that there are only two things. There are only two options, option 1 or option 2. This one and this one together, and this is saying that you get $50,000 and somebody else gets $100,000. Okay, you either press the button and get this, that's option 1, or option 2, you don't press the button and you get no money at all. Okay, so this is a false dilemma because we found a third option, shiny new third option. If you hate yourself, you actually get a lot of money out of this. Isn't that nice? Okay, so that's false dilemma. Remember to always argue like why a certain fallacy has that name, why we're picking and saying that this one, yes, it has a false dilemma fallacy in it. Okay, here's a straw man fallacy now. Okay, so apparently this was a news headline: coronavirus, Austria is banning all gatherings of more than 5 people. And so here's a nice clip from The Office saying that families of 6 apparently have to kill one family member so that they can remain in the same house. Okay, so the kind of argument that people could make from that headline is something like, yes, this ban is ridiculous. It makes no sense at all. Even families, they can't be together right now. Okay, so obviously this is not what the headline is trying to talk about. This is not what the law in Austria back in the day when the coronavirus was at its peak was talking about. This was gatherings of more than 5 people outside of the home, like other people, non-family members. Okay, so this was a straw man argument because it was never talking about families to begin with. Okay, straw man, remember, it's trying to argue, it's trying to bash down a weaker version of the argument. Okay, it's trying to bash down a weaker version of this idea, when in reality this ban never applied to actual families. They applied to like friends getting together, right? Okay, so that's the straw man fallacy. Now let's do one more, and then you can look at the slides for the other kinds. So this one's called tu quoque, and remember this is Latin for you two. And so this is always about when something's going wrong, like you're making fun of somebody, you're saying that somebody did something bad, and that person who did the bad thing spins it back around toward you and says, well, you too, you also did this other bad thing a week ago or something. And so that's a tu quoque fallacy, because it doesn't mean that the person who did the bad thing today was off the hook. Okay? So that's the idea. You can be a hypocrite, you can have done bad things in the past, but you can still call somebody out. And it's still a valid thing to say that somebody did a bad thing. Okay? That is the idea. So that's false dilemma, straw man, and tu quoque. Remember those, and go ahead and take a look at the other slides for the other fallacies. They are fun things to talk about. Okay? So that's the non-programming stuff. That was all. Okay? So now I want to move on and talk about Python, because yes, you're going to have an essay on the test, but I'm pretty sure you know how to write by now. And so Python is something that has been tripping a few of us up, and so I want to spend a lot more time there. Okay? That is my idea. So just you should do just fine on the essay part of the final, as long as you use all the tools that you've been building up over the normal essays in the class. Okay? So let us talk about Python. I have made you a fancy cheat sheet that I forgot to copy over, so I'm going to stop the video right now and pull it up, and I'll be right back. Okay, I am back. Are you ready? So I have made you this beautiful cheat sheet that I think might be useful for you. So it goes over different Python things, nice color-coded stuff, talking about conditionals, so ifs, if-elses, if-elif-elses. I'm talking about how the program gets executed. We'll come back here when we talk about those things. Talking about loops. You got your while loops, you got your for loops, and then talking about functions. So here's how you define a function, here's how you call a function and actually use the thing. Okay? That is the idea. So nice color-coded stuff. Hopefully that's nice and helpful, and I'll come back to this as I review. So let us do some Python, shall we? So sorry for the tiny font, but this is all useful stuff. So in Python, if you want to have a value that you want to that you can then go and use later, you like to put that thing in a variable, right? You like to use like x. I'm going to use x to hold 42, and then I can like use this x now instead of typing 42 everywhere in larger Python statements and expressions. So that is the idea. We can put stuff in variables, and Python has a bunch of different types of things that we can store, that we can use in the language. We can have ints, floats, bools, strings, and lists, and there are more, but we didn't talk about them. Okay? So let's just go to the REPL. I think that's enough for right now, and talk about those things. So 42 is an int. It's a number. You can ask it for the type of 42, and it'll tell you, oh yes, that was an int that you had. You can put it in a variable, x equals 42. Now x is there. You just say x, and you get the 42 back. And you can say type of x now, and x always just gets replaced with what it's holding. So it will say, okay, the type of 42, it's an int. Cool. All right, so that's ints, whole numbers, quite nice to use. Sometimes you don't want to store 42, but you want to store 42.5, right? So that's where floats come into play. If you want to store a number with decimal points, with decimal places, you use float. Okay, so you'll say 42.5, and what's the type of that? That is a float. Okay, you can store it in a variable, same stuff. And you can get it back. Numbers are nice by themselves, but obviously I'm sure you want to use them in bigger statements, so like you can add, multiply, divide numbers. You can take ints and divide them by floats if you want. Doesn't really matter. You can take one, give it to the power of the other. This is a very large number. This means times 10 to the 68. That was huge. So you can do all those cool things, and you can build them up, and you can save them in variables. It's just a nice time. All right. So that's in float. Something different though is bool. Bool is, I remember that all these types are clouds. Like you have the int cloud that holds like whole numbers, including negative numbers. ... The bool cloud is interesting because it only has two things in it. You can have a true value or you can have a false value. That's all you get in bool. Isn't that cool? That's very weird, but it's true. So true is a Boolean, named after George Boole, the man who invented this stuff. So it's a bool, and that's a nice thing to have. You can get bools back a lot of the time from comparing, like ints. Is x less than y? Hey, that's true, because x was 42 and y was 42.5. That's nice. And then, of course, you can combine your Boolean values with ands, ors, and nots, and that's quite nice to do. That's always very useful. It's like, okay, is x less than y and y greater than 0? That'll tell you something about x, won't it? That's true. Is x greater than y, which is false, and y greater than 0? Well, even though this side's true, this side's false, and you remember your AND rule, that's going to say no. It's going to say no, that this whole combined thing, this combined Boolean expression is going to be false. Okay? But because one side is true, you can use or. You could be like, is x greater than y or y greater than 0? Well, yeah, it'll take the true from this side. It'll say true, and then not, you can invert true to make it false, and false to make it true. Okay, so that's and, or, and not, and it's very useful to combine those things a lot of the time. Okay, so that's bools, and stir is nice when you want to have text. So you can be like, s for a string is hi mom, and so now I have s, it's a string, shortened to stir in Python, and you can do cool stuff with stirs. You can actually use arithmetic things. These arithmetic operations have been what's called overloaded for strings, and so if you say s plus, I don't know, blah, it just adds it to the string and makes a new string and gives it back to you. Or you can also use times and give it a number, like s times 3, and then it just duplicates your string 3 times. Isn't that cool? So that was nice for the Python people to give us that. And sometimes if you want to go through the string at each character, you can index into it like you can with lists, which I'm about to talk about. Then you use len. Len of s is how many characters are in this string. 1, 2, 3, 4, 5, 6, 7. Okay, so there are 7. Okay, now we have lists that we can talk about. So lists, like strings hold a bunch of characters, lists hold a bunch of just any value. It could be floats, bools, even strings. Or lists, you can have lists of lists, because why not? So these also have len, these also have plus, and the very important thing is they have indices, okay? So let's see, what do I want to do here? Let's like make a new file and call it something simple like, I don't know, let's just call it scratch.py or something. This is CSCI 1, this is lecture 32. So inside this folder, let's save like scratch.py, just like for our scratch work that we're doing here. So I can make a list, L, and it holds 2, 4, 6, 8, and that's fine. I can print it out, and I get the 2, 4, 6, 8. That's all well and good, but remember, like deep down, the list looks like this. It's in memory. It's got those 4 things, 2, 4, 6, 8. And if you want individual pieces of this list, you have to index into it. And so here's index 0, 1, 2, 3. Remember, it's very key that you remember that lists always start at index 0, okay? Index 0 if you want stuff out of it. So, I can say, where's the code? There it is. I can say print, what's the first thing in the list? It's L of 0, okay? That's the first thing. And if I want to print the last thing, how do I know, like, where it is? Well, what's the last index of this? I can use the length, okay? Because the length of L, that's 4. The last index is 1 less than that. Okay? That'll make my 3. So this will get replaced with L of 3, and that's the last index, and that'll work. I'll get the 2 and then the 8. Okay? Technically, you can also say L of -1, but I want you to do it the hard way so that you're understanding lengths and things for now. Okay? So, yeah, feel free to use -1 on the test, though. I wanted to show you it that way, though. So you can also add lists. There are essentially just strings that can hold anything. They're very similar to strings. So if I had a list, let's just make another one here. If I had a list L2 that held, I don't know, 10, 12, 14, I can add lists. I can print them out after adding them, L plus L2. That's just going to plop L2's information right after L's information. And so I get this big, longer list. That's the idea. Okay? So that's pretty much everything on this slide, all the different types. And this list is another type, I should say, just in case you were wondering. Print, or I guess I can just say in the REPL type of L, it was really a list. That's the type of it. It's a list of other types inside, but at the outermost level, it's a list. Okay, that's the idea there. Okay, we have input. Input is quite nice because you can ask the user for stuff, and you can make an interactive program that way. You can be like, what is your favorite number? Let's do something silly. Just be like print, or sorry, we can say input. What is your favorite number? And then leave a space so that they can type after your prompt here. And then this input, it's going to give back the value that the user typed. So I guess val, I guess we can call it. We can call it val. And this will store in val the input that we typed. Okay? So maybe we can output their favorite number times 2, right? It can be like print your favorite number times 2 equals, and then we can be like val times 2. Okay? There is an error right now. Do you spot it? If I type 42, what's it going to print out my favorite number is? So let's try and put the prompt over here and the code over here. What's your favorite number? 42. Your favorite number times 2 is 42, 42. What? And so remember what you get back from input, even if you type a number, input is only seeing the characters, okay? So the type of val, anything you get back from input is stir. It's always stir. Okay, remember that. And so if you want to, you always get a string back. If you want it to be the number, you have to convert the type over. You have to say, oh, I want an int out of val now, please. And that'll make the actual number 42. Okay? So just remember to do that. Just take whatever you get back, take the string, and always convert it to an int. You can do this on multiple lines if you wanted, but sometimes it's easier to just do it all in one. So now if I say, what's your favorite number? 42. Now it actually gets the int to the times 2. Okay? That is fun. So that's my little examples there. That is just all the different little types that you have in Python and how you can convert between them, and then also some variables thrown along for the ride. Okay, so now let's go to if, elif, and else. So this is part of the conditionals first page of this little cheat sheet. So let's talk about how if statements work. All right, so usually we have something that we're comparing. So we always want to do something if something else happens, okay, if something else is true. And so we always are going to use comparison and combine comparisons usually. So every time you say check for equality, disequality, less than or equal to of two things, all of those comparisons are going to give you back true or false, right? And the job of the conditional is to be like, okay, is x less than y? If so, if that's true, control what happens. If it was true, if it was false, do one thing, option 1, otherwise do option 2. And so that's what essentially an if statement gives you, okay? Technically an if-else statement here. So yeah, we use conditionals to control our program based on the results of a comparison, or if you just have a Boolean value, based on the results of a Boolean value that you got somehow, okay? So indentation, remember, is key. You have to say if, and then you have your condition, and then you have a colon, and then you always tab over. This is a tab. And then you have your body, okay? That's what a condition looks like, always. Okay, so that is what I want to talk about. And so let's go here and do this. Let's do example 1. You must be this tall to ride like an amusement park ride, let's say. Okay, so let's get the input from the user, and then we'll see if they can ride the ride. That's my silly example. Let's make a new file, and we'll call it conditionals.py. And so let's ask for the user's height. Int. Got to convert the input to, oh sorry, they could actually enter like with decimal. So let's say float of input. What is your height? In inches, I guess, let's say. And so maybe the amusement park ride can only be ridden if you're above, I don't know, 48 inches. How about that? Okay, so let's do this. So we can only ride the ride if we're above 48 inches. So if height is greater than 48, then we will say, oh, you can ride the ride. Okay, that is the idea. So we can run this, and it'll ask us what's our height in inches. Let's say 42 is our height, and nothing happens, okay? Because it just goes to the rest of the code. So if your code looks like this, it's always executing in straight lines, of course. So you do this one first, and then we go to the if statement. And what it does is it sees this condition and it checks it. If it's true, it does the body. If it's false, it just goes and does the rest of the code. And there happens to be no rest of the code here, okay? There's nothing down here. That is the idea, and so it just won't print out anything, and you'll just have to take that as, oh man, you can't ride the ride. Usually, though, we prefer to use an else statement. So use an if-else statement so that we do something if it's true, we have a body for that one, and if it's false, we have a different one, a different thing to do, okay? And so this is how this all executes. It checks the condition. If it's true, it does this body. If it's false, it does this body. And then it continues with the rest of the code that's unindented. That's de-dented or whatever down below. All right? So we'll add an else here, and we'll say, you are too short, you can't ride the ride. And because I used a quote here, it stopped the string a little too early. And so the way that you can fix this is you can use double quotes for your strings. Alternatively, you could have escaped this one with a backslash, and then it would have been happy. Okay? So now it says you can't ride the ride if you are under 48 inches. So this one says now, it goes straight to the else case, says you can't ride the ride. And if it was true, if my height was, I don't know, 49, we'll say that you can ride the ride. And maybe we should say greater than or equal to, because if we are 48 inches, we should be able to ride the ride. Okay, so that is if and else, hopefully not too bad. Let's now do the complicated one, which is Elifs. Okay, so remember that Elifs give you a bunch of options. So it's like, okay, if this one wasn't true, then let's try this other condition. If that one's true, then we'll do something. Otherwise, if it's still false, if that one also is false, let's do this other thing. Or maybe there's another nested bunch of conditions down here. Okay, let's do a grade calculator for calculating grades. So you enter a grade, and then it'll tell you your letter grade based on the number grade. Okay, so grade equals float input, enter your grade, and so we should give like a colon and a space to give you some room to type, and then we'll check the grade and figure out like what we should give back as the actual grade. Okay, what is the letter grade for this number grade? Okay, maybe we should say grade percentage. So here's what we want to happen. We want to have a bunch of Elifs because we want to check first if it's an A. If it's true, we'll print the A. If that's false, we'll try another condition. We'll see if it's a B. If that one's true, we'll do that one. We'll do this body and print out it's a B. Otherwise, if that's still false, we'll try some more options. So here's an if else, and you can have as many Elifs as you want. But remember that they only ever execute one body, the body of the first condition that worked. Otherwise, at the very end, they do the else. Okay? So it's always finding the first condition that's true. If that one's true, it does this and stops. It goes straight to the after. See that? Otherwise, if this one's true, it goes and does this body and goes straight to the after. Then it's done. Only one body ever gets executed. That's the idea of an if, elif, else. Okay, so let's do it just as I said. So we'll check if the grade is an A. If grade is greater than or equal to 90, 90.0 for fun, then we'll print A. Okay, and if that's false, we can say elif and try another option. If grade is greater than or equal to 80. If that one's true, we're going to print the B. Okay, and so we'll keep playing this game for a while. We'll check if it's a C, check if it's a D, and if it's none of those, we'll check if then it's just else. None of these previous conditions worked, and so it must be an F. Okay? Sad time. This one will be for C's, this one will be for D's, and so this is 70, 60. Okay? And so here's the idea. It's always going to check the conditions in order. If this one's true, it'll do this one. Otherwise, if this one's true, it'll do this one. The elif kind of means otherwise. All right? Only ever one of these bodies. Only does one of these ever get run. Okay? So let's do the C option. Let's do like 75.5 is my grade. Oh, sorry. That's my height. Here's my grade percentage, 75.5. And here's what it's going to do. It's going to say, oh, is it 90? Is it greater than or equal to 90? No. All right, let's try this one. Is it greater than or equal to 80? No. All right, let's try this one. All right, is it greater than or equal to 70? Yes. Print C, we're done. It goes down and does the rest of the after code. Okay? That is how if, elif, else's work. Isn't that fun? So, yeah, that is the idea. You just try a bunch of options in order. The order really matters because if I checked for D's or F's first, then it would always just print D or F, because if I had this as like greater than or equal to 50, if I did like the D's first, maybe greater than or equal to 60, and printed D, it would always have this one being true, even if it was an A. See that? So the order really matters. Just remember that it's always going to check them in order. This condition, it tries first, then it tries this one, and then so on and so forth. Okay? And it only ever does one body. So that is my rant for conditionals. Okay, so that's that. Let's talk about loops now. Okay? So let's do while loops. While loops are nice because they allow you to repeat code. So if you can see my mouse right now, it's going from the condition to the body, keeps on checking the condition. As long as it's true, it keeps executing the body of the loop. Okay? That is the idea. That's how we want while loops to work. Okay, so yeah, let me do a few examples there, and we'll get to see while loop. So it's always about conditions still. If we want to print all the numbers from 1 to 10, we'll use like an I, be like I equals, starts at 1, is I still less than or equal to 10. If that's true, we'll keep on printing I. And going back to check the condition, that's how the loop rolls around. And then finally, if that's false, this is the true side. If it's false, then we're done. Okay? You just do the rest of the code. Do the after. Okay? So that's my example 1. Let's do it. So I'll make a new file called loops, or do I want to call it loops? Let's just call it while.py. So example 1, print all the numbers from 1 to 10. Oops. Okay. So the idea is we want to start at I equals 1 while I is less than or equal to 10. We want this to always be true when we print something. So I'll start at 1 and it'll go between 1 and 10. Print I. And then we should also increment I equals I plus 1. Okay, so that'll print from 1 to 10 because it keeps on printing 1, I is 1, I is now 2, it's still less than 10, prints 2, I is now 3, still less than 10. It always keeps going back and checking that condition, okay, before it executes the body again. That is the loop. That's where the looping happens. Okay, if you want to ever stop a loop early, if you didn't like that the number got so large, an easy thing to do is to break, okay? So maybe we don't like the number 7 or something. If I is 7, stop early with break. We just say break to break out of our loop. And so it only prints from 1 to 6 now. That is the idea. Okay. So that is that one, example 1. Let's do example 2 now. Let us get a bunch of numbers from the user and sum them up. Okay, so the user is just going to keep on typing numbers, and we're going to keep summing them until the user types -1. That'll mark that the user's done typing things. Okay? So that means we should output the sum of these numbers. This -1 doesn't count. Okay, that just marks the end. That's the idea. All right? So that is how what we'll do, and let's talk about how we'll do it. So the idea is we want to keep on repeatedly getting numbers. If it's -1, we're done getting numbers. And I'm going to keep track of the sum of all the numbers that we've seen. Okay, so I'm going to try and translate this to code, and it should be helpful to watch me think, to hear my thought process. So if I need to keep track of a sum of a bunch of numbers, and I don't know how many, I want to start my sum at 0, so that I can just add into that sum variable, make it bigger over time. Okay, that's the first thing. And then, if I want to loop, I'll need a while, but I don't know how often to loop. I don't know when I'm done. So maybe the best thing to do is to loop forever, infinite loop, and then break whenever I know that I'm done. And that will be that -1 here. Okay, that's the idea. So repeatedly, forever, until the end of time, until the user types -1, let's get a number from the user. So num equals, just pretend that the user's typing ints, int input, enter the next number, and then we've got the number now, and we want to keep track of the sum, so we need to add that number that we just got into sum, okay? So that's what needs to happen. Sum equals sum plus num. And between these, though, we need to make sure that we're not done. Because if this number was -1, we don't want to add it to the sum. We want to stop the loop, okay? So if we see -1, we're done. So if num is -1, we're done, break out of the loop. That actually stops this otherwise infinite loop. See that? Isn't that nice? So sum equals sum plus num, and we're off to the races because that's what's going to stop the loop. Otherwise, we're going to add into our sum. Then when we're done, by the time we exit the loop, the correct sum value is saved in the variable. Okay, we've built it up each iteration of the loop, and now we're ready. We're ready to print out the answer. The sum is, and then we can give that sum to the user. Okay, so here's how we can do it. We can be like, okay, enter the next number. 42, 43, 44, 1, 2, 3, and each time I've done this, it's getting that number, checking if it's -1, if so, stopping the loop, finishing the iteration early, doesn't do this line. Otherwise, it continues to this line and then repeats the loop. It's like, okay, I'm going to continue because my condition is true. I'm always going to continue if my condition is true. I will get my number was -1, I'll add it to my sum. Okay, so it'll have that actual value by the time it finishes the loop. Okay? And so, if I say -1 here, that's going to stop it. Sum is 135 apparently, because this stops the loop and allows us to continue with the straight line code below. All right. So you can always start with -1, and that means you had no numbers. Their sum was 0. Okay? That's the idea. 1, 2, 3, 4, 5. -1. Sum is 15 of those. 9, 10, 11, 12, 13, 14, 15. Yeah, it sure is. Okay? So that's while loops. And then the other kind of loop is for loops. Okay? So a for loop is a loop that has something to iterate through. Okay? Usually that's a list. Either a list or a range, right? A range is technically making something that's very similar to a list for you. Okay? It can be converted easily to a list. So if you have the list 1, 2, 3, and you want to go through each element and do something to each element, like if this is your list L, a for loop is a great thing to use. And then range like 50 is essentially gives you back a list 0, 1, ... all the way to 49. Okay, it's always one less. So those are what you get. Let me just prove that to you, and then we'll stop for the day. So range 50, it's not technically a list, but you can convert it to a list and use it like a list in a loop. Whee. So that really is 0 through 49. And so we're going to talk about how we can use for loops to iterate through the lists that we have, and we'll get to that in the next lecture. So I'll stop here, and I'll see you in the next lecture for the rest of the stuff. Okay? So I will see you then.